Dead Men Tales is brought to you by SupplyHouse.com, the easy way to order HVAC, plumbing, and electrical parts. Shop online, find a wide selection of products from industry-leading brands, and get fast delivery anywhere in the U.S. And being a pro has its perks. Apply to be a SupplyHouse.com Trade Master and get access to a dedicated phone line, free shipping and returns, and discounts on every order. Join the thousands of trade pros already benefiting from their free membership at supplyhouse.com/trademaster. That's supplyhouse.com/trademaster. From heatinghelp.com, it's Dead Men Tales. I'm Dan Holohan. When hot water heating was brand new, the Dead Men installed a lot of gravity systems because they were safer than the steam systems of the time. Up in the attic of those homes, you would usually find an expansion tank that was open to the atmosphere. To fill those systems, you'd have to carry buckets of water from the well to the attic and empty them into the system. After a while, though, and after city water became available, someone came up with the idea of using a ball cock in the open tank to keep the tank filled. Then, if a tank waterlogged, the excess water just ran out onto the roof through an overflow pipe. No problem. Some of those early gravity systems didn't have attic tanks. The Dead Men would instead connect their cast iron radiators across the bottom push nipples and leave a portion of each radiator filled with air. The collected air in the tops of all the radiators became their expansion tank. This is sure to have you scratching your head if you've never been on one of those jobs before. You'll spend a lot of time wandering through that house looking for a tank that's not there. And then you'll bleed all the radiators and watch the relief valve pop. After the circulator came along in the late 1920s, the pipes got smaller and there was less expansion going on because there was less water in the system. The Dead Men abandoned those open expansion tanks in the attic, which were prone to freezing, in favor of closed steel compression tanks, which they usually hooked up to the butt end of a flow control valve down in the basement, and for a time there was peace in the valley. But before long, the Dead Men learned that almost without exception, the compression tank would lose their air cushions and fill with water. No one was quite sure why this was happening. They'd solve the problem by making it their habit to drain several gallons of water from every tank on every visit. This led to the common practice of draining all compression tanks, whether or not they needed draining. Generations were raised on this belief. If you see a steel compression tank, you drain it. Case closed. And that's how it was done for years. But then the diaphragm tanks arrived. Diaphragm tanks don't need to be drained, but they do lose their air pressure over time. That's because the diaphragm is made of rubber, and rubber is a semi-permeable membrane. Gases will pass through the rubber and into the water at the rate of about 1 psi per year, which is why you should always check the air pressure before you throw away one of those tanks. But let's get back to those steel compression tanks for a minute. The air sits on the water like cheese on a pizza. When the circulator runs, it can't add any water to the tank because the circulator is operating within a closed system. For the circulator to add water to the tank, the circulator would first have to remove some water from the pipes. And if it did that, there would be an empty space in the pipes where the water used to be, and that's simply not possible. In a similar way, when a circulator runs, it can't take any water out of the tank and put it into the pipes because the pipes are already filled with water. And for our purposes, water is not compressible. So follow this. Since the circulator can neither add nor remove water from that compression tank, there won't be any pump flow in the line going up to that steel compression tank. With no flow, the water in the tank will be cooler than the water in the pipes because the water in the pipes is passing through the boiler. Okay, now for a bit of science. Gases will dissolve in liquid in proportion to the pressure and temperature of the liquid. That means that as water cools, it absorbs air, and when water gets hot, it releases that air. Now, since the water in the compression tank is relatively cool compared to the water in the pipes, it will absorb some of the air that's inside the compression tank. That's only natural. Here's what happens next. The hot water in the pipes rises by buoyancy into the tank as the cold water in the tank sinks down into the pipes. These flows pass each other in a single pipe that connects the compression tank to the system piping. We call this gravity circulation, and it has nothing at all to do with the circulator. It's just a natural phenomenon. Now watch this. The air that gets absorbed up there in the tank eventually winds up in the piping because of this gravity circulation. And once that air-laden water comes up to temperature, the air gets released as bubbles. Those bubbles get pumped out to some radiator where they settle out of the flow because the water's velocity out there in the system is usually less than it is closer to the circulator's discharge. Someone winds up venting the radiator, and that lowers the system pressure. The fill valve senses this and opens, allowing fresh water to enter the system. That new cold water goes up into the tank because that's the only place that can accommodate it. Remember that the pipes are already filled with water. So every time this happens, there's a little less air in the compression tank and a little more water. That's how steel compression tanks get waterlogged. The way to prevent it is to use a special fitting that's designed to stop gravity circulation between the tank and the system piping. Bell & Gossett's air troll tank fitting is a good example of what I'm talking about. These things have been around for longer than I have, and they work well. Sometimes those old-fashioned devices deserve a second look, especially if you're spending a lot of time draining steel compression tanks. I hope you enjoyed that story, and if you did, please share it with your friends. And if you haven't already, please subscribe to this podcast. I have lots more Dead Men Tales to share with you, and I'm really enjoying our time together. Thanks for being here.